All right. So we'll get going here. It's got a good number of people in here, similar to yesterday. I am in a room where hopefully no technical issues today. So just to make sure, can someone do me the favor of unmuting their mic just to make sure I can hear you?
Can you hear me?
I got you. Awesome. So we will dive into it. So share my screen with you. We'll pick up where we left off in slide one. Kind of left off talking about marginal decision making. I'll work through a kind of similar example and add some things in that I didn't have yesterday. So before I do that, just some logistics of the class I wanted to mention before we dive into material. I got to thinking about it, and I understand, once again, it's summer, schedules are a little bit different. And so I want to have some flexibility for you guys if I can. And I have two sections. So my other section is from 2 to 3:30 in the afternoon. If for whatever reason it doesn't work for you to attend the live lecture and you still want to, you can attend this live lecture as well. There's no physical constraints or anything on how many people are in Zoom, or at least given the number of people we have. And so this is also an option. So I've got the link to that virtual class as well. And the only difference is the code will not be this section's number, it'll be that section's number, so 4935. So if you ever want to, you can always go back to this first week of slides. I've updated the slides on Canvas to include this slide. And I believe yesterday, right, I put the link up to kind of the recording from yesterday. So I'll put another announcement up here that has that information, just so you don't always have to go back to that first week of slides. You can go to that announcement that has that information about the other section, if that is an option that you need to take advantage of one day. But other than that, any questions for me before we dive into? I have one more thing actually. I have a meeting at 2 p.m., which is why I joined. Oh, that's fine. You can join the earlier class. That's not a problem at all. Like I said, that was actually something I had hadn't thought of. I didn't mention yesterday, but I wanted to mention today. Now, when it comes to the daily quiz, if you're in a different section, I release those during class. Now, they're not like due by the end of the day. Those are usually, like, I think, due by the end of the day Sunday. And so you should have plenty of time to kind of open those up, but you might have to do it. Your sections might not be available if you're attending the live lecture of a different section. I also reached out to the Top Hat rep. So I think some people were getting some issues where they already paid for e-text through the university and weren't getting access to Top Hat. I was told this morning they removed the paywall on that. So if you've already paid through the bursar or whatever it is, it should be available to you. So if that wasn't working yesterday, please check today to make sure, because that first module reading for module 2 will be due before we start class tomorrow. So usually it's due before we start covering the material. I said a little bit of grace period here in this first kind of couple days, just because we're going to get everything going. We will start on module 2 here pretty shortly once we start class. Okay. All right. So hopefully everyone can now see the dot cam here. In fact, let me zoom out just a little bit. Oh, that does let me. So we had yesterday, I kind of had this goofy example of like how, me paying for a beer or something like that. And so typically what we want to think about, and here I had like the number of something. So we'll eventually start calling this quantity, right? But this is kind of the number of whatever product we're looking at, right? This could be a product. This could also be the number of hours I put towards studying, or the number of hours I work, etc. Then typically on this kind of y-axis, we're going to measure these marginal benefits and these marginal costs in terms of the dollar amount. Okay? So I had this example yesterday where you can kind of think about, let's do some numbers here that look a little different than yesterday's, just for the sake of this example. So at 1, let's do 18, 2, let's do 15, 3, 12, 4, 9, and then 6. Not drawn to scale. But here would be kind of, if we could look at, fractions, so not 1, 2, 3, but 1.5 or something like that, we could actually draw this nice kind of continuous line that represents the marginal benefit of a different quantity of this product, or the marginal benefit of putting a certain number of hours towards studying, towards working, etc. Okay. So I mentioned last class, typically we think of the very first unit of a good we buy, or the first hour we put towards something. That's what's going to have the highest marginal benefit, right? So if you think about studying, that first hour you study, I mean, you're seeing the material, working through it for the first time, that's going to have a huge benefit to you. By the time you're studying like 5 hours, you're going through the same stuff again. It's not having near as large of an additional benefit to you. So we've got our marginal benefits here. We can also think about, I think last class I drew you a constant marginal cost. Let's just think about one here, where if I were to measure these marginal costs, let's say or something like this, and we'll put some numbers to it. So we've got like what? Let's do 13 here. Looks like right here, I'm at 12. Here, let's do 11. Here we'll do 9, and then here we'll also have 6, okay? So we said last class, I should choose to buy something, I should choose to put another hour of studying, I should choose to do something as long as that marginal benefit is greater than the marginal cost. In fact, eventually we'll say we will choose to do something or buy something. This comes up more in module 3, but if it's greater than or equal to. If these were equal, the additional benefits would be the same as the additional costs. You can kind of think about you're no better or worse off, right? The benefits completely offset the additional costs. So when we're thinking about the optimal choice, how much of this product would I buy, or how many hours would I put towards this certain activity? What we're really doing is saying, okay, look, for that very first unit, right? If the marginal benefit of 18 is greater than the marginal cost of 6, well, we could almost think about when do I choose to do something? It's if the net benefit, which we can calculate as the difference between marginal benefits and marginal costs, if that is positive. Because if that is positive, that's telling me the additional benefits are greater than the additional costs. So here, what? I've got net benefits of 12. If I kind of keep on going down here, I've got what? That second at 15 minus 9 is what? 6. At the third unit, 12 minus 11 is 1, 4. Well, now the marginal benefits are less than the marginal cost. So hopefully I know I shouldn't be choosing to buy that fourth unit or to put that fourth hour towards something, because there the net benefit would be -3. And then here, what I've got 13 minus 6. So a net benefit of -7. So you can kind of see here, when should I, how many of this product should I buy, or how many hours should I put toward this activity? Well, when the marginal benefit is greater than the marginal cost, I should choose to purchase that unit or put that hour towards the activity. The net benefit will be positive. Marginal benefit greater than the marginal cost. My net benefit is positive, so I'll choose that one. Net benefit is positive. Well, what about here? Well, now it's negative. If I choose to buy that fourth unit, the additional benefit is less than the additional cost. I'm actually worse off. Remember, we said we assume that people are self-interested and rational, so that why would I make myself worse off? So anytime that marginal benefit becomes less than the marginal cost, we will not choose to buy that good. So here our optimal choice would be to stop at 3. Now, if we had a scenario where these ended up being the exact same value, so they were both 11 and the net benefit was 0, we would still say we choose that up to that point where they're equal. Okay. And this will start to kind of foreshadow us a little bit into module 3 once we get there for supply and demand. But for now, we're just thinking about additional costs and additional benefits. So any questions on that before we keep moving? Okay. All right. So, okay. There we go. Get out of the way, Zoom. So, some other things to kind of wrap up for module 1. Just some terminology stuff and just kind of setting us up for the rest of the semester. But we're going to have 2 types of statements. So one of them is going to be what we call positive statements. So even though we're using the word positive, that doesn't mean that like they're good or bad. It's just that it's more of a statement of fact. So it's what people actually do, right? So this would be an example. If I look at the data, I can get I can make positive statements. If I look at a bunch of, excuse me, uh, spending and income data, I might see that people save on average 5% in the US. That is just a statement of fact. That's what the data says, right? Now, normative statements are opinion-based, right? It's what we say or what we think people should do, right? So, for example, if I'm looking at retirement, saving 5% annually isn't going to give the average person enough money to kind of live after they retire at 65. So, a normative statement, people don't have to save more than 5% if they don't want to retire at 65, but if they want to, we can say that people should be saving more than 5% annually, right? So this is an opinion, right? They don't have to do that, right? But if they want to be able to retire, we can say that they should be doing that, okay? So positive are facts. Normative statements are opinions. That's the easiest way to kind of boil it down, okay? So normative economics, like that's just your opinion, right? If you guys don't know this movie, cult classic, you should watch The Big Lebowski. I'll drop in some terrible memes and movie suggestions throughout the semester. So economics is also considered a science. So it's not a hard, physical science, but it's a social science. So we still kind of follow the scientific method. We're going to develop models and theories, right? Those models might have certain assumptions, right? Just like you in a science class, like a physics class. We're then going to design an experiment to test this theory. Usually these experiments are designed for us. This is people living their everyday lives, companies making decisions every day. We then look at the results of those experiments, collect the data, right, from when these things are happening in the real world, and then we see, does that data support our theory, right? Um, so, in these models, what we're going to end up doing, and you have to make some simplifying assumptions, which is that if we ever want to understand the relationship between two things, so X happens, what happens to Y, right? So X, I'm like just like a variable. We have to hold everything else constant, right? And so in all these models, when we're looking at changes, eventually we'll look at things like, okay, if the price goes up, do people buy more or less? And how much more? How much less? We're assuming everything else stays the same. Their income has stayed the same. Market conditions have stayed the same. So we're a ceteris paribus, everything else we're holding equal. Now, obviously in the real world, everything is changing constantly, right? So we are just saying if we could hold everything else constant, and there are ways to design experiments to hold those things constant, we want to know what's just the effect of a price change or whatever the example is, right? So by holding these other things equal, we can isolate what the effect of a single variable is. So we'll do a lot, this is a little bit designing these experiments to be something outside the scope of this class, but all these models we look at will start to say things like holding everything else equal. If the price changes, what would happen to the quantity people buy? Okay. I've got kind of just a little example. We can kind of think about how does this play out in practice. So usually these models are simplified representations of the real world because we are holding all these things constant in order to isolate that one cause and effect relationship between two different variables. But we can test it with real world data. So I've got a link here. It has the Fed put it out, and it's financial returns to a college degree. So you might think about, okay, how do I measure? You're all here trying to get a college degree. What is the marginal benefit to you? Well, I think most people think about the marginal benefit in terms of, well, how much more money can I make? So we're just going to look at what is the impact of another year of education in terms of the increase in your salary, right? So maybe we have an old theory and it has a mathematical model that suggests that it should be increasing your earning potential by 50%. That's our theory. We go out, look at how much people are making with and without a college degree. We gather data, collect data. We then use that data to test our theory. So if we looked at the data, and this was, I think, from got another link here. People actually did this. I think this was the BLS. I grabbed this from. We'll see in a second. The average starting salary for someone over 25 with a college degree is going to be about $1,400. For someone over 25, the average earning, I think this was weekly, with a high school diploma is 853. Okay. So we can already start to think about something we've talked about. Well, what's the marginal benefit? And once again, this is, I believe, weekly data, right? So what would the weekly marginal benefit be in terms of salary for having a college degree? Well, it's not $1,400, right? Because by working with a college degree, what am I not doing? I'm not working with a high school degree, right? So I'm comparing kind of what is this change in salary. So it's about what? 600-ish dollars there would be the marginal benefit every week. Well, an additional 4 years of education, right? We could kind of think about how much, what's that percent increase? Well, if I actually calculate the percent increase, right, it's $600 more, but the percent, if I take this kind of ratio, it's actually a 68% increase from this initial starting salary of 853. So we collected the data, we saw what the actual percent increase was. It's greater than our original theory. Our model's wrong. We need to go back and rework our model. It wasn't predicting that the gain was as high as it actually was when we were looking at the real world data. Now, this is where it gets a little tricky because when I was gathering this data, was I really holding everything else constant? No, right? People who have a college degree are, there's a lot of other factors that we aren't holding constant. One is typically their parents are more likely to have a college degree, higher earning potential. They might likely be able to have more financial assistance in pursuing that college degree and may have better connections to get a better first time kind of job coming out of college. And so we have to take these results with a grain of salt, right? We can't, we weren't really truly holding everything else constant, and our model was. So maybe the model, even though the data doesn't align with it, we probably have to design an experiment where we're making sure that we hold things like parental income and some of these other factors constant. But this is the general idea, right? And this is where I was getting that, yeah, it was the BLS. That's where I was getting that weekly salary data from. And don't feel like you have to always check these links. I try to, if I'm giving you numbers, I always try to put the link in there just to be kind of transparent. I'm not just making these up. And so, with this idea in mind, we have this 68% increase, but that's the average, right? That's the average increase from having a 4-year degree. For some people, it may not be as large, right? Why might someone with a college degree actually be earning less than someone with only a high school degree? Well, all of you probably have similar degrees because you're in B251, but I'm going to go out on a limb and guess theater majors aren't having as large of a starting salary as, say, a finance major. So that increase in wages might be pretty accurate for a finance major, right? Or might be even understated, but it's going to be overstated for someone with a theater degree. So we're talking about average effects a lot of the times. We have to realize for any one individual, this may not be the case, right? Or, if you think about Bill Gates or Mark Zuckerberg, someone, if you even go, who got a college degree and then their starting salary went way more than 68%, right? So we want to be careful, this idea of correlation versus causation. Our goal is to get causal effects, right? But a lot of the times when we're looking at data, there's just a correlation, right? So another age-old example is like ice cream and child drowning deaths. If you look at ice cream sales, they pretty strongly positively correlated would predict higher drowning deaths. What are kids getting sugar, highs than going comatose after they crash and then they're more likely to drown? No. When are ice cream sales and drowning deaths more likely to be high? When it's hot out like right now, right? So there's this outside factor that we thought we were holding constant, but we're not, right? And that could be driving both of these things, all right? So that's just a correlation. It's not necessarily causation. So how do we get at causation, right? That's a lot harder. It's probably something we really don't even talk a whole lot about in this class. If you keep on going, I believe you'll take, forget what the stats equivalent is. I know in the econ department it's 370, but it's a stats course where you start to understand how to differentiate between causal relationships and just correlations. Okay. All right, so that rounds out module 1. We'll now kind of start with module 2, unless there's any questions. I want to make sure I give a second here. Okay. So if we go to Canvas, before we start module 2, I've got that first quiz kind of ready to go. I'll publish that after class today. If you go to the Files tab, I've got a set of practice problems and the answer key up there. Now, some of the questions in that first quiz will also just be related to things that were in the syllabus. So having the slides pulled open, having these practice problems in front of you when you take that quiz would be something I highly suggest. Once you start it, you'll have 60 minutes to complete it. And you can start it, whatever fits in with your schedule. Once it's released and it's due by the end of the day on Sunday, I've got it set. Okay. Any questions before we dive into module 2? Okay. All right. So module 2, right? We're going to kind of take a little bit of step back, talk about something that kind of looks like macroeconomics, and we'll mention some macroeconomic stuff. But really at its core, we still have a lot of microeconomic principles in understanding the production possibilities curve, abbreviated PPC here, right? So we start out the most basic economic model. We can think about, let's say we have an economy. And this economy could be one person. It could be an entire country. Right? So we'll think about an economy, and they can produce two things. So I've got what? Produce. I probably should change this to be, wheat or something like that. But I'm thinking of like corn or wheat, some type of a produce product, and then computers. Right? So I've got a scarce resource, which we talked about last class. That's the general economics problem, is how do we make decisions facing scarce resources, which is labor. And I've got 50,000 labor hours per month I can devote towards either producing computers or some type of agricultural product. Right? So, and here I think I chose wheat to make it, so I'm not saying produce, right? Produce wheat, right? Make it a little bit easier. So if I produce computers, it takes 100 labor hours. So this product requires a lot more labor hours than a ton of wheat. So I've got kind of this setup where I think about there's these different combinations of these two goods that I could be producing. Now, in practice, there's a lot more than 5. We're just going to start out with 5 to kind of make it easier, right? So I could produce only computers. If I put all 50,000 of my labor hours towards that, well, if 100 labor hours gets me one computer, I divide this by 100, I'd have 500 computers, but I'm not putting any of my labor hours towards wheat production. I get 0 tons of wheat. And then here's these other combinations. We go to the other extreme point. If I put all of my labor hours towards wheat, how many tons of wheat am I getting? Well, each ton costs 10. So divide this by 10, I'd have what, 5,000? And then kind of a similar thing, if I have split my labor hours in between the two products, here would be the resulting quantities or the resulting production that I have. Okay. We're all okay with that so far. Okay. So I left this open. And here's where it's going to get tricky. You guys can still see the doc cam, correct? Just want to make sure before I done. Okay. So I need to be able to see these numbers so I can match it up. So when we have these production possibilities curves, we're going to start thinking about, cheat here a little bit, so make sure that when we talk about it later, it's easier. Start out with wheat. Okay. So we'll do the quantity of wheat down here, and we'll do quantity of computers down here. Okay. Do I want to do it that way? We'll start. I think that one's a little tricky. We're starting out here. Let's walk before we can run. Let's do computers on the x-axis. Sorry, changing my mind mid problem here, but I think this will work out better for you. So here, if I'm only producing wheat, so that point where I was putting all of my labor hours towards wheat production, I had 5,000 tons of wheat, 0 computers. If I was only producing computers, we had what? 5,000, no, what was it? 500 computers and 0 tons of wheat. Now, all of these points in the middle, for right now, are going to lie on this line in between those two extremes, right? Where I'm only producing wheat, where I'm only producing computers. So one of those points, point B, was what? 4,000, and then 100. Point in the middle we had was 2,500, 250. And then the point down here we had was 400 and 1,000. Okay. So typically in these production possibilities curves model, if I'm asking you to calculate costs, I will give you something like this. We'll make it a little bit more difficult or kind of, push it a little bit further here in a second. But really all you need in order to understand what the cost of producing one more computer is to have these two extreme points here. Now, having the points in the middle, right, we might want to be able to determine why we know we can produce that combination of the two goods. And we'll use the cost here in a second to kind of convince ourselves of that. So when we talk about the production possibilities curve, we're assuming we can only produce these two products. If we want to have 3, 4, 5, it's the same logic, but the math gets harder. We got to do like matrix algebra. We're not doing that in this class. So we're just going to only look at models where we have two products. So if I want to produce a computer, what is the cost? So if I start to put labor hours towards computer production, what am I not putting labor hours towards? Wheat production. What did we say marginal costs are? It's partially opportunity costs. What could I have been producing? What am I giving up? So by putting labor hours towards computer production, I'm giving up some wheat production. Okay. So how can I determine for every computer that I'm producing, how many tons of wheat am I giving up? Well, from the graph, right, all you would have to do is figure out, well, what's the slope of this line? Because the slope of this line tells you if I want one more of what's on the x-axis, the slope is how much I have to give up of whatever's on the y-axis. So here, if I use these two extreme points, what's the slope of a line? It's the change in y over the change in x. Or here, change in the quantity of wheat over the change in the quantity of computers. Didn't save myself enough room here, so we'll do the work down here. Well, how much wheat am I giving up moving from this point to this point? I'm losing 5,000 tons, right? I'm going from 5,000 to 0. How many computers am I gaining? 500. So here, the slope is -10 because the slope will always represent a cost. It is the cost of one more of the x-axis good. So this is going to be the cost of one more of the x-axis good in terms of our y-axis good. Okay. So for us, it's the cost of one more computer in terms of the tons of wheat that I have to give up. Okay. Any questions on that? And I'll give you a couple different ways of thinking about this as well. So another way you could have looked at this with our kind of labor hour example. Remember, every computer was what? 100 labor hours. Every ton of wheat was 10. So if I wanted to produce one computer, how many tons of wheat could I have? If I want to produce one more computer, if instead I had been producing wheat, how much could I have produced? 10 tons, right? That was my cost. But I think, most of the examples I give you, I'll give you the actual quantities. And so calculating the slope of this line using the quantities is going to be how we determine that cost. Okay. Now you'll also notice if I really had wanted to, I could have used any other point here and calculated the cost, and it should be, if this is a straight line, should be the same. So notice here, what was the change in my y-axis good? Was -1,000. What was the change in my x-axis good? Was going up by 100. Sure enough, I end up calculating that same cost. So it doesn't matter which 2 points we use, we would calculate the same marginal cost here for the x-axis good. Okay.
Question really quickly.
Yep.
So when you are dividing like the y-axis by the x-axis,
Mhm.
how do we know which like quantity we should put on which side? Should we just do whatever the larger number is on the y?
So I did the larger number to make the math a little bit easier. Um, Now, what did I say the slope of this line represents? It's the cost of one more of the x-axis good. So this is a good question. So whatever you want to know the cost of, I wanted to know the cost of one more computer. That's the good I have to put on the x-axis. Does that
Okay,
answer?
thank you. Yeah,
So,
it does.
but in combination to your question, or kind of extending it, so we just found the cost of one more computer or PC was 10 tons of wheat, right? So that was the cost of our x-axis good, right? So this was what was on our x-axis. If I wanted the cost of my y-axis good, which was wheat, what I can actually do is just simply take 1 over whatever the cost of my x-axis good was. So it truly doesn't matter. So in this case, that would be what? 1 over 10. So the cost of 1 ton of wheat is 1/10 of a computer. The reason, so it doesn't really matter what I put on my x-axis. The slope will tell me the cost of that x-axis good, but I can always find the cost of the y-axis good by simply doing 1 over that slope. All right. Okay. Now, if I want to, if that gets a little bit tricky for me, I could always say, okay, well, I found, I put computers on the x-axis. I found the cost in terms of wheat. How could I have done this instead of doing this 1 over if that confuses me? Well, if I want to know the cost of wheat, where should I put it? On my x-axis. Then the slope would tell me the cost of wheat. So if I put wheat, I just flip those. Right? Now my two extreme points would be 500 and 0, and then 0 and 5,000. So now if I calculate change in y over change in x, or the slope, now the change in y is negative 500. Change in x would be 5,000. And sure enough, I get 1 over the cost of a computer, right? So I can flip the goods and then look for the new slope, and that will tell me the cost, the marginal cost of my x-axis good, which is now wheat. Or I could have simply done, well, I know it's on the y-axis in my previous model. I could just do 1 over the cost of computers, which I have in the x-axis. So that slope is always telling you the cost of your x-axis good. So if it's easier, if you want to know the cost of something, draw out your production possibilities curve and put it on the x-axis. Okay. But if you can kind of understand this idea, you can maybe save yourself a little bit of time. If I asked you for the cost of both goods, instead of having to draw out two different graphs, you really could just draw out one, find the slope, that's the cost of your x-axis good. 1 over that would be the cost of your y-axis good. Any
Thank you.
questions? Sorry, do you have a question or is?
No, I was just saying thank you because
Oh,
that made
okay,
it make a little bit more
perfect,
sense.
perfect. All right. Any other questions on that before we jump back here to the slides? Make sure this, where's the chat at? Okay, so we're back, right? So once again, I leave some slides blank when I do work on the dot cam. So this was kind of getting practice here. That's where I drew that production possibilities curve. We kind of already get this out of the way. Went through all of this, right? But if you want to know the cost of your x-axis good, so one more unit of the x-axis good is always your slope, right? And I had technically had to put a negative sign in front of here because that slope will always be negative. And when we start to talk about costs, costs are inherently going to are negative. So we typically would say like the cost of one more computer is 10 tons of wheat. We wouldn't say negative tons of wheat, right? Okay. So we now know how to determine the cost of different goods to different economies, or even if this was at the individual level, to different individuals. So once we start to look at all the people within an economy, costs can vary, right? So if you think about like the CEO of Ford, maybe they can fix their own car in an hour, right? And some mechanic in Bloomington, excuse me, can fix it in 3 hours and would charge $200, right? So even though the CEO of Ford can fix this car in a much smaller amount of time, why might they still drop their car off at the mechanic? What's true about that 1 hour for the CEO of Ford? It's very valuable if he uses that hour to do work for the company, right? So should the CEO fix his own car, pay the mechanic? Well, he can do it in a shorter amount of time, right? But that time is also very valuable, right? So if we think about the CEO has a time, valuation of his time of $2,500, well, should he pay the mechanic? Well, I mean, 3 hours, $200, paying him 600, but my time that if I put that hour towards the company, I can earn the company or kind of earn myself in terms of salary, $2,500. Well, what would the net benefit be? I'd be better off putting that hour towards work and having the mechanic fix my car, right? So, and I think here it wasn't even $200 an hour, it's just $200 total. Sorry. But either way, it doesn't matter, right? So we know that costs can vary. We know costs between individuals, between companies, between countries can vary. And so how do we determine who should be producing what products, right? Just because someone can do it in less time, fewer labor hours, doesn't necessarily mean that's what's better, off cost-wise, right? Because everyone's hours may have different valuations to it. Right? So if we have this idea in mind, we have two terms that we'll kind of talk about, which are absolute and comparative advantage. So an absolute advantage just means that if I'm putting the same number of resources towards producing something, I can produce more of it. So if I am taking the same number of labor hours, that CEO of Ford could fix more cars than the mechanic could, right? If they both put, say, 3 hours in, the CEO could fix 3 cars, the mechanic's only fixing one. We would say that that CEO has an absolute advantage. Right? So a comparative advantage is, okay, just because I can produce more of it using the same amount of resources, those resources might have a different valuation between the two people. And as a result, I might have an absolute advantage, but if I choose to do this, it's going to be at a much higher cost. So comparative advantage says not just can I produce more if I use the same number of hours, but can I produce it at a lower cost, right? So in our example, the mechanic would actually be the one that has the comparative advantage. Right? The CEO, the cost of his time was so high that if he chose to produce, or he or she chose to fix their own car, they wouldn't have the lowest cost, right? They'd be giving up $2,500. They actually do not have a comparative advantage in terms of fixing the car. So kind of a little toy example to set up this idea of thinking about absolute and comparative advantages. What we'll typically do is kind of compare it across countries or firms or individuals. And so I'll usually give you something that looks like this, which is these are two different countries. This could be two individuals, two companies, whatever it is. And here's the two products that they could be producing. So if the United States is only producing iPhones, this is the total number using all their resources they can produce. Now, obviously, these numbers are simplified to make the math a little bit easier, and so we're not dealing in thousands and tens of thousands, hundreds. So, but what these numbers would represent is using all of their resources, the US can produce 60 iPhones. If they use all of their resources, they can produce 30 aircraft parts. So I'm essentially giving you those two kind of intercepts for a production possibilities curve, right? If I'm producing only iPhones, no aircraft parts, I can produce 60. Or the US can produce 60, only aircraft parts, no iPhones, they could produce 30. And then similar for India, right? I kind of got their numbers there as well, 50 and 10. So we're going to draw out, right, who has an absolute and comparative advantage. Well, just from these numbers, it's typically pretty easy to see who has an absolute advantage, right? So using all their resources, who can produce more iPhones here? The United States. Using all of their resources, who can produce more aircraft parts? The United States. So we would say that the United States, in this example, has an absolute advantage in the production of both goods. Okay? That's not always the case. Sometimes one person has an absolute advantage in one good and the other person in the other, but you can have it where you have an absolute advantage in the production of both. Okay? So we can use our PPC. So we can use it to understand who has an absolute advantage. It's easy to compare the numbers. What's a little bit trickier is determining who has a comparative advantage. So in order to do that, the PPC makes it a lot easier for us, right? So if these PPCs represents the trade-offs between producing these two goods, it tells us what the costs are. Well, remember, what is a comparative advantage? Who can produce this good at a lower cost? So if we can use the PPC to calculate costs, we can use it then to determine who has a comparative advantage. Okay? So here I kind of have it drawn up, right? Sorry, the blue line would be India. So if they're only producing aircraft parts, that number we had from the previous slide was 10, only iPhones 50, aircraft parts for the US 30, 60 iPhones. So if the intercept of that country's PPC is at a greater value, that's telling us they have a absolute advantage. Now, who has a comparative advantage? We want to look at the slopes here, okay? So once again, if I want to know the costs of one more iPhone, right? What's the cost of one more iPhone to the US? Well, how do we find the cost of the x-axis good? We said we would simply calculate the slope, right, of the PPC. So what's the change in y? 30. What's the change in x? 60. In fact, do I have it up here? Yeah, there we go. So change in y 30, change in x 60. Every iPhone is going to cost the US half of an aircraft part. Now, technically, I should have had like a negative sign in here. We end up, remember, multiplying it by a negative sign just because when we're talking about costs, they're already inherently negative. So here we've got the cost or the slope, or the PPC is the cost of an iPhone for the US. Now, visually, because I have this drawn to scale, we can see if I have a flatter curve, is India's cost going to be higher or lower? Well, a flatter curve means a slope closer to 0. So it should be that India has a lower cost to iPhone production. Okay. So if we go ahead and calculate India's costs for one more iPhone, it would be what? 10 over 50 or 0.2. Okay. So who has a comparative advantage in iPhone production? Well, who can produce one iPhone at a lower cost? India. So with an absolute advantage, you're looking for the larger number, right? But for a comparative advantage, you're looking for who has the lower number, right? Who can do it at a lower cost. Okay. Everybody okay with that before we keep moving here? All right. And so I want to do this here. So we just did US, India, and we'll do cost of iPhone here. So this is what? 0.5 aircraft parts, 0.2 aircraft parts. Right? So I feel like this is not focused the best, but so I could redraw those production possibilities curves. So if I know that India has a comparative advantage in iPhone production, what'll end up being true is I can't have a comparative advantage in these two product models. I can't have a comparative advantage in both, right? So the reason why is because if we think about how would I find the cost of an aircraft part? Well, remember, if I know the cost of my x-axis good, how do I find the cost of my y-axis good? That would simply be 1 over the cost of the x-axis good. So 1 over cost of the x-axis good. So here I get what? That the cost for an aircraft part, what was on our y-axis, for the US would be 2, for India would be 5. Who has the lower cost? The US. So we would say the US has a comparative advantage in aircraft part production, right? And this will always be the case that you can only have a comparative advantage in one of those goods because it's just a law of mathematics. If I have the lower cost to this good, when I take the reciprocal, like 1 over, this is always going to be a larger number, right? So you can always prove this to yourself by actually calculating the values and seeing, oh yeah, now they have a higher cost to the production of the other good, but it'll always be the case. So if you really want to, once you find who has a comparative advantage in one good, so if I know India has the comparative advantage in iPhone production, I automatically know that for the other good, the other country or the other person has to have the comparative advantage in that. Okay. Is that ringing a bell from some high school math classes there? Questions on that idea? Okay. So once again, if you really wanted to, I guess you could have redrawn the whole graph and flipped the goods, but I think hopefully once we start to get this idea down that once I know the cost of one good, the cost of the other good is just 1 over that, makes it a little bit easier. Okay. And then, so we already determined who has comparative advantage in iPhone production. We said that was going to be India. Okay. And then we kind of already worked through this as well. If we want to find the cost of the other good, we just 1 over, right? Cost of the Y good, 1 over the cost of the X good. We can now determine who has comparative advantage in aircraft part production. Here, that would be the US, lower cost. Okay. All right. So where are we at on time? So we got what, 30 minutes? So we have plenty of time. So we'll save this here. This is going to be something I'll kind of come back to. No, do I want to do that now or later? I want to do this now, and then we'll kind of go back and look at a problem here. Well, no, we'll save gains per trade. So let's do. So here's the participation quiz for today. Let's look at. I'm going to build it. I'm going to preview it, and we'll kind of work through some stuff that we've already talked about. A little bit of review here in the middle. So if I had PPC that looks something like this, so I've got, this is a kind of, this might seem dumb, but this is like a, I don't know, 1700s economic example. I have an economy, I can produce either war goods or goods to feed my people. So guns and butter is kind of like an age-old example. So if I'm only producing guns, I can have 600. Only producing butter, I can get what, 800, I don't know, tons of butter or whatever, however you want to measure it. So if I'm using all of my resources, how many guns can I produce? So if we want to know how many guns can a country or a person produce only putting resources towards that, the intercept is what tells us that value. So if I want to know how many guns can this economy produce, it's where is that y-intercept, or where is the intercept for guns? It's at 600. So we should have 600 as our answer there. Right? Now, if I had asked you, I don't think that's the next one, right? But if I had a question that I asked, using all of your resources, how much butter can you produce? That would be the intercept for butter, or the x-intercept here, which would be 800. But the question was asking about guns, so we've got 600 as the answer. Now, if I have the same example, but I want to know what's the opportunity cost of producing 1 more unit of butter for this country, how would I find my opportunity cost? Well, that's the slope of my production possibilities curve. So if I want to get 1 more unit of butter, how much of the y-axis good do I have to give up? That's just the slope. So I said always use these 2 extreme points to calculate the slope. That's probably going to be the easiest way. You can, try to use these points in the middle here and say, oh, okay, looks like here it's 450. I could choose this point. It's going to 300. You'll always have the values for these extreme points. And so here, what's the change in y? I'm going from 600 to 0. Change in x, I'm going from 0 to 800. So 600 over 800 should give me that every unit of butter is costing me what? 0.75, if I'm doing math in my head correct there, 600 over 800, 0.75 guns. Okay. Any questions on that? All right, and then we'll save this one. I'm not sure if we'll quite get to it by the end of class here. If we do, we'll kind of jump back into this participation quiz. So now that we can, hopefully we're feeling a little bit more comfortable with calculating these costs, determining absolute comparative advantages. Why do we want to know who has a comparative advantage? Well, we can actually, from these values, determine or prove that trade is actually beneficial to both individuals. So if we allow people to produce only what they have a comparative advantage in, and then trade, they'd both be better off. So we'll work through an example where we can show this. So if I'm thinking about the example that we were just working through with aircraft parts and wheat, we know that any number, let's go back. So if we think about India, right, the cost of one more iPhone, the cost of an aircraft part to them would be 5 iPhones. So if the US says, hey, look, I'll give you an aircraft part, how many iPhones will you give me? Well, India says, I know if I produced it myself, I'd have to give up 5 iPhones. So if I give the US anything less than 5, I'm actually giving up less than if I produced it myself. So if I only have to give the US 4 iPhones, I'm getting an aircraft part now, at a lower cost than producing it myself. And then same kind of idea. How many iPhones would the US be willing to accept? Well, the US says, I know that if I stop producing an aircraft part, I'm only going to get 2 iPhones out of it. Right? If I put my resources from that one aircraft part towards iPhone production, I'm only going to be able to get 2. So India could really offer them anything above 2 and they'd be better off. Right? If India says, I'd give you 4 iPhones, the US says, okay, I'll produce the aircraft part and I'll trade it to you for 4 iPhones. Because if I stop producing it and produce the iPhones for myself, I'd only get 2. So I'm better off if I trade with you. So therefore, there's going to be this range where both individuals are okay with any kind of what we call terms of trade, right? Or can come to an agreement if the value or the cost of one aircraft part agreed upon is anywhere in between each country's costs, right? Anywhere between 2 and 5. Okay. So this terms of trade, we first have to determine what the costs are for each country. But once we know those, we know that any value in the middle there, countries can come to an agreement upon, right? If it was 3 iPhones, 4, 3.5, these would all be values where trading with the other country, I'd be better off than if I tried to produce it myself. If India trades 2 iPhones for it. So I wouldn't think of it necessarily as profit, but they are better off trading 2 iPhones for an aircraft part than if they produced it themselves. So if they give up 2 iPhones for an aircraft part, if they would have produced that aircraft part for themselves, they would have had to give up 5 iPhones. So they are better off. Their net benefit from trade is positive. So I wouldn't call it necessarily profit, but it would be like their net benefit from trade. Does that answer your question?
Yeah, thank you.
Okay, perfect. All right. So, what if we did the reverse, right? Well, it's going to be the exact same kind of logic that how many aircraft parts would the US be willing to give up for an iPhone? Well, they know that they want to produce the iPhone themselves, they have to give up half an aircraft part. So as long as India is willing to give, give them anything, uh, or sorry, if we're thinking about what's the cost of an iPhone, we know that it's going to cost the US. Oh, when I go back here, right? Cost of an iPhone, half an aircraft part, right, for the US, and then 0.2 for India. So how many aircraft parts would the US be willing to give up for another iPhone? Well, they produced the iPhone, on. Is this not what I want? Is it iPhones being on the aircraft parts? Is the US going to go for another? Yeah. So if I want to get one more iPhone, what amount would I be willing to give up, right? Well, if I want to get an iPhone, it's going to cost me half an aircraft part, so anything less than my own cost, right? I'd be willing to give up, if I produce it myself, I have to give up half an aircraft part, so I'm willing to give up anything less than half, right? And then how much would the iPhone be, or sorry, the iPhone, how much would India be willing to accept in terms of aircraft parts to give up an iPhone? Well, if they stop producing an iPhone, they get 0.2 aircraft parts, so anything above that. So our terms of trade will always be just in between the costs of the two countries. So if it was for an iPhone, it's in between the two costs, or sorry, in between the two countries' costs for an iPhone. Okay. So I would show you another way of doing this before we keep going here. Yeah, so instead of drawing the graphs out every time for these terms of trade or determining comparative advantage, here's another way you can do it. Might make it a little bit easier. So I think this was what, 60, 50, 10, and 30 was the numbers I gave you. Let me see if I got a marker that's a little bit more. So you don't have to do it this way. It just might help some of you think about it. So I'm going to draw the exact same kind of little table here, but these numbers were how much I could produce if I put all my resources towards producing these two goods. Down here, I want to produce a table that just tells me the costs. So when I was drawing these out, remember, if I wanted to know the cost of an aircraft part, I was putting aircraft parts on my x-axis, calculating the slope. So here, if I want to know the cost of one more aircraft part, what I can do is essentially turn whatever good I want to know the cost of, I can make that a 1. This will make a little more sense, I think, in a second. So how could I turn 30 into 1? By simply dividing it by, I'll do it in a different color to kind of show this. Divide it by 30. Right? Well, if I divide this by 30, then I have one aircraft part. Now, if I divide this by 30, notice what is that really telling me? That's telling me the slope of that production possibilities curve, or did I get these numbers wrong? No. All right. Let me make sure. Looking back at my, yeah, those are the right numbers. So here, by turning whatever good I want to know the cost of into a 1, dividing the other good by that same value, for the US, one aircraft part is going to cost me 2 iPhones. And then same kind of thing for India. How would I get this to be one aircraft part? Divide it by 10, divide this by 10. Now I've got the cost to India of one aircraft part would be 5 iPhones. So now that I know the cost of an aircraft part in terms of iPhones, my terms of trade kind of should just, well, here, I'll write out the whole word. So terms of trade would just be in between the costs of those two countries. And then I could do a very similar thing. If I wanted to do the terms of trade for iPhones, I would just, how do I turn iPhones into 1? Well, I would divide this by 60, divide this by 60, divide this by 50, divide this by 50. So if I wanted to know the cost down here, all right, I'll do what? 60 over 60 would be 1. 50 over 50 is 1. So I've turned iPhones into 1 because that's what I wanted to know the cost of. Now, how do I find the cost of air? Well, divided this by 60, so 30 over 60 is 0.5. 10 over 50 here, 0.2. So now I have what's the cost of one iPhone for both these countries in terms of aircraft parts. now my terms of trade here is just in between the cost of the two countries. Okay. If this is a little confusing, you can always just do it using the graphs, but if this kind of connects with you, sometimes people, I think, I tend to see this lines of, clicks a little bit more for them, kind of doing it in table form, but either way should lead you to kind of get that correct answer. Okay. All right. Any questions on that before we keep moving? So one thing you can kind of see for those terms of trade is they're really just reciprocals of each other. That's because how are we finding the costs of the y-axis good? Just 1 over, or the reciprocal, right? So let's see, once we can determine these terms of trade, let's actually show why trade would be beneficial. So you'll have to take me at my word a little bit on this, but let's say we started out with two countries and they weren't producing just one good. So they were somewhere in the middle of their production possibilities curve. So if we go all the way back here, they're producing like here and here, right? 2 points in the middle of their production possibilities curve where they're producing some of both goods, okay? So if they were doing that, and let's say the US is producing 15 iPhones, 22 and a half aircraft parts, that's a point that's on their curve. India is producing 25 iPhones, 5 aircraft parts, that's a point that's on their curve, right? If I start from this point, right, how might I have gains from trade? Okay. So let's say we said what would be a possible terms of trade that both countries agree upon? Well, the cost of an aircraft part for each country was 2 and 5 iPhones, so somewhere in between that range. Okay. So let's say they agree upon 3 iPhones, right? That's the terms of trade. Every aircraft part, if a country gives the other one an aircraft part, the other country would give them 3 iPhones. So we said who has a comparative advantage in the aircraft part production? That was the US. So before trade, we had these two values. Let's say the US agrees to give 5 aircraft parts to India. In return, they would get 5 times 3, 15 iPhones. Okay. So if they're producing only aircraft parts, right, and then they're giving up 5 to India now for 15 iPhones, how much would they have after trade? Well, remember, they could produce 30 aircraft parts total using all their resources. So they would now have, they gave up 5 aircraft parts, so 25 aircraft parts, but they got 15 iPhones back from India, right? So notice, oh, if they did it themselves, they had 15 iPhones and 22 and a half aircraft parts. They're now better off, right? And then India, if they only produce what they have a comparative advantage in and then trade, so they only produce iPhones, they could produce 50. They're giving 15 to the US, so they now only have 35, but the US is in return giving them 5 aircraft parts. They are now, before, if they did it themselves, they only got 25 iPhones and 5 aircraft parts. They're now getting 35 and 5. Both countries, right? Here, India has the same number of aircraft parts, but more iPhones. The US has the same number of iPhones, but more aircraft parts. So this is just one possible combination. You could work through and improve this to yourself for any terms of trade in between 2 and 5 and any kind of number of aircraft parts or iPhones being traded between the two countries. Any questions on that idea before we keep moving? So, oh, you don't like free trade? Those are some sweet Nikes you have, all right? So, every country is better off if they produce what they have a comparative advantage in, and then we allow countries to trade. So when we put these trade restrictions, all we're doing is hurting our own populace and hurting other countries as well. Right? 10 minutes left. What do I want to do? I think we'll start with this next. Well, I'll do this next class, and then maybe I'll just give you the answer to the quiz question. So we now have this idea that different countries have different costs of producing a good. Right? So we're now going to look a little bit more micro and think about, okay, within a country, we've looked at simple models up to this point where the cost to that country, right? There is only one country, and so we're just calculating one cost. But we know within a country, there's tons of different individuals, right? So if we think about people producing aircraft parts, someone who has, you know, much more knowledge than I do about the mechanics of an aircraft could probably their labor hours would be much more efficient towards aircraft production than mine are. So within an economy, within a country even, there's many people. So we want to think about whatever good our economy is producing. So I'm just going to call this X, any good that we're producing, right? And here I'm going to measure in dollars what the cost would be, okay? So cost. Who am I going to rely on to first start producing a good? Whoever can do it at the lowest cost. We could even think about this as like, what if we were drawing out the worldwide production possibilities curve? Who are we going to first rely on? So in our example, let's do aircraft parts, right? What was the cost of an aircraft part? Who had the lowest cost? I believe that was the US, or wait, no, I forget my numbers. No, the aircraft part, yeah, it was the US. They were only giving up 2 iPhones, if I remember correctly. So initially, I'm not going to rely on India. If I'm like a world czar and I'm determining who gets to produce aircraft parts first, I want the person to produce it first, whoever can do it at the lower cost, which was the US, right? Now, eventually, the US will have used all of their resources, they're only producing aircraft parts. So now at this point, for our entire economy, or our entire worldwide economy, I think the numbers would have been if we were both producing iPhones, it was what, 50 and 60, so we would have started out at 110. Well, the US, each aircraft part cost them 2 iPhones, so now we're down to 50 iPhones from India, 30 aircraft parts from the US, right? So this middle point here that I've got is where each country is only producing what they have a comparative advantage in. If I want to go past this point, who do I have to start relying on to produce aircraft parts? Well, the US has used all of their resources. They don't have any left. I have to now start relying on India, and their cost of an aircraft part was a little bit higher. Now, when we say higher here, a higher slope, this production possibilities curve, it's always negative, so it's steeper. Right? So what's going to be true, and this is a very simple, like 2 country in the entire world, there's many more countries than 2. So what's going to happen when we look at like a worldwide, not just the US and India, it won't be like just these, kind of 2 curves. It would be every country and kind of their increasing cost. Now, we still rely on whoever can produce at a lower cost. So initially, our slope is always going to be relatively flat, right? Whoever has the cost closer to 0. Now, as we have to start relying on, countries start to use all their resources and we have to rely on the next lowest cost country, their slope is a little steeper. And then the next country, a little steeper, until we get to these countries where the cost is really high and we have a really steep slope. So our production possibilities curve in terms of like the entire worldwide economy is going to be downward sloping and kind of have this like downward bend to it. Does this, any questions on this idea before we keep moving here? Okay. All right, so 6 minutes left. What do I want to do here? So we talked about this a little bit. I know that the economy's on. We'll revisit this and pick up on this idea and go a little bit more in depth here. But what I'll do for you now is kind of this economy-wide production possibility curve zone. And I will go through that last question of the quiz, and then we will call it a day. So we'll revisit this starting next class. But we'll use it to understand something here. So let's say I've got 2 goods, an X good and a Y good. This could be whatever that. It could be computers and wheat, any of these other examples that we've talked about. We just said an economy-wide production possibilities curve is going to look something like this. So in my example, I was using countries and thinking about the worldwide economy, but really, even within a country, well, different firms or different individuals have different costs, and so our production possibilities curve isn't going to be as simple as a straight line once we get to looking at an entire country. It's actually going to have this nice kind of bow to it. Okay. Now, in all the examples that we worked through earlier about determining costs, things like that, I'll give you the more simple models where it's just a straight line. But we're kind of now, we got to walk before we can run. We're now starting to run. Okay. So any point on this curve is going to be a combination of these two goods that everybody in our economy, we have enough resources to be producing any one of these combinations. Now, every single one, I'm using all of my resources. And here I'm getting a lot of Y and a little of X. Here I'm getting a lot of X and a little of Y. So which one of these is preferred? That's a question that we'll hold off on until next class. But any point on this curve is possible, right? I have enough resources to be at these production points. So the easiest way to think about this is, so this would represent if everybody in my economy is producing good X. So if this is using all my resources, how much of good X I can produce, if I instead chose to produce here, what must be true? I'm not using all of my resources. So any point under the curve, so that could also be, well, here, if I instead was producing here, well, I've got the same amount of X, but I've got less of good Y. If I know this is a possible point I could get to, I'm not using all of my resources. So any point under the curve, we're going to say is production inefficient. And the lights are going to turn off on me, of course. I guess I got to wave my hands or something, move around a little bit more in this room. So any point under the curve is inefficient. Any point on the curve, we would say is production efficient, if I can spell. And then, well, what about every point past here? Well, why am I not producing here? Well, because I was using all of my resources. So if using all of my resources, I had this much X and this much Y, I can't keep the amount of X I have the same and produce more Y because I'm out of resources. So any point above that curve, we would kind of label or call unattainable. We don't have enough resources to get out to that point. Okay? So any point on the curve, production efficient. Any point underneath the curve, production inefficient. Any point above that curve, unattainable. Okay? So I don't know if this is in the skeleton version of the slides. I think I put it in the complete version. But if we're thinking about a question like this, which point would we say is inefficient? And I believe this should also line up with the last question on the quiz today. Which point is inefficient? Well, point C is on the curve. Point B is on the curve. Those would be what we call production efficient. I'm using all of my resources. That's what the production possibility curve represents. The combination of these two goods that I could be producing. Now, which one will I be producing? Once again, we'll talk more about tomorrow. Point A is going to be a point where, well, it's above where I'm using all of my resources. So that would be unattainable. And then point D, well, I could be producing more of both goods, right? I know that this is a possible production point. So point D must mean I'm not using all of my resources or that I'm inefficient, right? So point D would be the inefficient point here. We had what, 0.75 was our cost earlier, and then 600 was if we were using all of our resources, how much this economy could produce, okay? All right. Any questions on anything before we wrap it up here? We'll revisit the production possibilities curve, why it's kind of that downward slope and kind of that bow out shape, and pick up with that tomorrow and finish module 2. That module 1 quiz I will release as soon as I get back to my office, and that's due at the end of the day, Sunday. And then you'll have this participation quiz, which is also going to be available. I get on and get that done since you got the answers here. Just get on, make sure you get those easy points. Okay? Any other questions before we end it here? All right. Feel free to email me if you just were shy and want to ask your questions. Otherwise, I will see you guys tomorrow.
Bye, thank you.